So consider the following two binomial heaps. So the first one has got B0, a B1 and a B2. Second one also has the same structure, B0, B1 and B2. You can place appropriate values. Let's assume this one is 1 and this one is 5, 10 and this one is say 20, 30, 60 and 70. This one is say minus 5, minus 10, 100, 4, 10, 20 and 25. So the binary representation of this will tell you 1 B0, 1 B1, 1 B2. So there are 7 nodes. Similarly, this one also has got B0, B1 and B2. What do we do when we do the merge? We see that 1 plus 1 is 0. You get a carry 1 and then we merge these three. That is as good as adding 3 ones. So we get 1 as part of sum. Carry is 1 and then we get 1 over here and finally this structure. Correct? So that shows that in the resultant structure we will have a copy of B0, B1, B2 and B3. So you merge 1 and minus 5, we get to see that we will have minus 5 followed by 1 and we also have other structure, so 5, 10 and minus 10 and 100. So when we have 3 ones at this place, which means there are 3 copies of B1. One copy is created because of the merge of these two, that is minus 5 and 1, and second copy is from the first binomial heap, third copy is from the second binomial heap. Now what are we saying? We say you retain 1, it could be anything. Let's retain this. We retain this and merge the other two following our min property. So we get minus 5, 1, 5 and below that 10. So we create a copy of B2, that is what this says. You create a copy of B2 and retain 1 copy of B1. Retain 1 copy of B1 and create a copy of B2 by merging the other two. Fine. Now you see that there are 3 copies of this. So one is minus 5, 1, 5, 10. Another copy is 4, 10, 20, 25. Third copy is 20, 30, 60 and 70. Here again we retain 1. Say we retain minus 5, 1, 5, 10 and merge the other two following min property. So you get 4, 10, 20, 25. On the other side 20, 30, 60, 70. So what this says is you retain 1 copy of B2 and create a copy of B3. That's precisely what this says. You retain 1 copy of B2 and create a B3. That's precisely what we have done. So from this stage we got 2 of them and we are retaining 1 copy of B2 and create a copy of B3. Fine. So now what is the resultant structure? Resultant structure, there is no B0 and there is one B1 which is minus 10 and 100. So we have a copy of B1. Then we are retaining a copy of B2 which is minus 5, 1, 5, 10. Then we have a copy of B3 which is 4, 10, 20, 25 and 20, 30, 60 and 70. So at the first level we are merging two copies of B0 and create a copy of B1. Now there are three copies of B1, retain one and merge the other two to get B2. That is essentially what we are seeing over here. This one says we create B2 on merge of these two, retaining one copy of B1. Then now we have three copies of B2, retain one and merge the other two to create a copy of B3. And we are done with our operation, and the resultant structure has got one B1 and one B2 and one B3. That's precisely tells you that the binary representation of this structure is precisely this. You can see that there are 8 nodes here, 4 nodes over here, 12 nodes over here. That's precisely the binary representation of 14. And in this you see that you scan through this, you also scan through this. So for this one it is theta of log n. In general, merge is order of log n. Fine.